Hi folks, and welcome to another episode of The Art of Engineering. In today's episode, we're going to do part 2 of Battle of the Bulbs. The 6v6 versus the 6L6. Now in part 1, which I'll link below and probably in the end screen as well, we managed to ascertain that the 6L6 gave us about 1.5 watts more at the plate voltage that we'd set up for the 6V6. Now the plate voltage for the 6V6 was around 290 odd volts, and I went to double that voltage to 498 because I was thinking higher plate voltage will probably get quite a bit more wattage out of the transmitter, but unfortunately it's at that point the cheap inverter that goes DC to AC, which is the way I'm generating my plate voltages, decided to fry itself. So I am in the process of building an old school power supply. But in the meantime, I looked online and found a cheap inverter, ordered it, and it arrived very rapidly. So I'm happy to say it's arrived. I'll just show you it. It's retail therapy, and during the week, that retail therapy is always something to look forward to. I looked at the measurements for it. I didn't realize it was as large as it is, and it is quite a large inverter compared to the last one I had. So the plan is, it was nice having it as an integrated part of the transmitter, but as this is not a portable rig anyway, what I'm going to do is I'm going to have this sitting on the outside of the box, and it has a little fan on the back of it. So if it starts to overheat, that will provide it with the ventilation it needs. And we will set this inverter up and have a crack at using that voltage doubler circuit, and we're going to see whether we get more power. So stick around and either see the smoke, or see more power, or maybe see my disappointment. Let's go. Turbines to speed. Okay, so this is where we left off. That's where our inverter used to live, and that is the remains of the case for our inverter, which I will keep because I can put a small QRP transmitter in this little box. It could definitely come in handy. I'm just going to show you the comparison of size. And there you have it, folks. There is a whopping difference of size, hence it not going back inside that very, very cramped box. Now, at some point in time, we also had a bit of a short circuit on the tube socket. That wasn't the last breakdown, but a previous one. But I may also just give that, I should really replace it, but I think I'm just going to give it a really good scrub and get rid of any carbon deposits or whatnot so that it doesn't arc out at the higher voltage. We love a well-stocked junk box, and that is exactly what we're looking for because we want to be able to plug in. So that is brilliant. We'll just utilize this cord. We shall also run this inside the DC. Get that connected up, so they only need to use one 12-volt input. And then fingers crossed, it'll behave itself. Otherwise, this is just a very, very expensive, well, not a very expensive, but a little bit of a folly nevertheless. But, you know, the plan B will be the old school supply that I'm building, which no doubt will serve me probably more reliably than this will. So, didn't have to go shopping. Once again, the junk box has provided us with what we need. So we will run this inside to get 12 volts. Run this cord inside as well from the front of this. Off we go. So we go plug in here. That takes out 200 volts, 230 volts AC inside to the doubler. This goes inside to find our 12 volts, and this will just sit next to the transmitter, making loud hissing noises as it explodes in my face. Okay, we just went out and woke the neighbour's dogs up. It's not too late, so we're not past that magic hour where we can't do any drilling. I don't like to do it when it's dark, but it was only 2 holes and it was very, very quick. Well, we've got that plugged in now, and we're just going to see whether we're cooking with gas. That's off at the moment. Turbines to speed. Did we get our polarity right? Yes, we did. That is a good start. Let's wire up the big power now and see what happens. Well, folks, a very interesting turn of events. We shut the lid on this and we got it going, and it was misbehaving and we're having all sorts of difficulties. And then all of a sudden on the 6v6 I managed to get 10 watts out. If you remember from video 1, we only got 5 or 6 watts out. And then on this as well, we are presently on the 20 watt scale, and we're up around 11 watts. So there's obviously an issue with some of the wiring inside here that's in a minute. One of the wires popped off, so I think we had a dry joint, but I also think that the tube holder really copped a scorching, and I'm pretty sure there's a lot wrong with it. So I have spare ones. I am going to rewire that tube holder, and then I'm going to have one more go at the voltage doubler. The voltage doubler didn't work the first time I tried it, but I have a sneaking suspicion that may have been down to the problems with the wiring when I shut the box. So I'm going to give it one more try. But as you can see there, it's giving me 11 watts on the 20 watt scale. So even if that's all it's giving me, that is a good amount of power for CW for me. I will definitely leave it like that if that need be, and it'll give me 11 watts on the 6v6 or 10 watts. So, you know, I'll probably just put the 6v6 back in it if the voltage doubler doesn't work and I don't get more power out. If the voltage doubler works, I'll probably leave the 6L6 in it. But watch this space. Let's see what happens. Well, we have made sure that we've taken a record of where all the wires went, because it is an absolute bird's nest in here. And as you can see, that's the what happened the last time the thing caught on fire. And I was not happy with the way the old plug was wired up anyway, because I felt like as I closed the box, there was always that chance that something that wasn't shrouded correctly could actually arc out and cause me issues. That is the old socket. And what I did discover was, while I was actually taking the wires off this, one of the wires just fell off. So that's most likely what the problem was intermittently anyway. But hey, it's always nice to get back in here and replace this with something that's not so completely and utterly trashed. We are wired back up again. Let's put it back on the QRP playground and see if it fires up, and then we'll reinstate the voltage doubler and see if we can get a higher plate voltage. Good, that's working. Well, I guess it's time to reinstate that voltage doubler and see if we can get a higher plate voltage, and one that's not too high. That'll be the other problem. Okay, voltage doubler has been reinstated, and we're going to flick the switch and see whether we get a green light. No. It appears that the circuit does not like, or this inverter does not like, that voltage doubler. Down the track, we will be building a transmitter that is utilizing the 6L6 with a higher plate voltage once we finish the next project, which is coming up, which I will discuss in the wind up for this video. So folks, what have we discovered? We've discovered that the inverter does not like the voltage doubler. In fact, the last inverter absolutely cacked itself when plugged into the circuit. This one obviously has a little bit more protection inbuilt and has survived the onslaught. I've discovered that, be it a 6V6 or a 6L6, with the plate voltage that I've got, I am getting a very, very nice and ample 10 watts with a crystal. Well, since that repair, the 6V6 is actually giving me, on my VFO, before it was giving me like a watt. And now with the 6V6, it was giving me 3 watts. Now we've put the 6L6 in, and doesn't that look so grand, having a beautiful vacuum tube like that in the rig? And we are getting close to 3.5 watts. So I am very happy with that. As this is the QRP playground, I think it's befitting that we remain below the 5 watt threshold. And we'll see what we can do with this rig when it's paired with the DX160, and maybe have a bit of fun trying to QSO on it. Okay folks, the end of another very eventful weekend. I had a great time this weekend playing with my tube transmitter. We also had the Remembrance Day competition, and I bashed out a few CW quick QSOs and a few SSB QSOs on the new amplifier here, which worked really well on SSB and on CW. And since I've implemented that amplifier, which is a very modest, probably 40 watts, just over 40 watts, I am working DX really, really easily. I've done some CW, had one CW call from here to Paris. I've had heaps and heaps of FD8 DX, so it's been really, really great. But the plans moving forward, the tube rig will be operating at 10 watts on a crystal, QRP on the VFO, until I can be bothered doing something about that. But we will be building higher power tube transmitters, CW transmitters, and we're going to do it old school using a power supply. Now, this is the box the power supply is going to be built on top of and inside. And what I've done is I have a couple of these transformers. That's one of them, and there is another one. Trust me, yes, it's just over here. Got these delivered from Jaycar. I'm not sponsored by Jaycar, but they're just across the road from the school I work at, and I should be. So back-to-back transformers is going to get us on the road to having an isolated transformer. Now, these have 15 and 30 volt secondary, so I'll be able to switch between the two between here to get a couple of different plate voltages. I've also got myself another full wave bridge rectifier, bit of mains cord, some 3-pin regulators that I'm probably going to use with a bypass transistor to make it higher current, so that I can create different heater voltages, all that good stuff. I know I probably should use a transformer, and Chris VK2 NAP has advised me to do that, but at the moment I just want to play with what I've got and then go to what I should be doing when it doesn't work, which is what normally happens. Thank you for sticking around right to the end of the video. This is the upcoming project, like I said. Sorry I'm rambling, but it's getting late and it's time to go to bed because it's a school day tomorrow, 7/3, and I'll see you in the next episode of The Art of Wrecking Stuff, aka The Art of Engineering.